Okay, so this lesson is simply called the unit circle. All right, our objectives today are going to be able to construct the unit circle, okay, make it ourselves, and we're actually going to do that twice today. And then we're going to use the unit circle to evaluate trigonometric functions, okay? So what is the purpose of the unit circle? Like Tristan kind of hinted towards, it is a tool for us to use to find and to evaluate trig functions. So we've kind of been doing it the long way, but once we have the unit circle, it's going to be able to help us, okay? I'm going to come back to the stuff at the top, okay? I'm going to go down here. Now, this should look familiar because we've talked about radian measures, okay? So I'm going to go around this whole circle and just, I guess, divide it up into degrees, all right? So remember, an angle in standard position looks like this right here. This is our kind of our starting position, and that is 0 degrees. Okay? How many degrees is this? And I'm going to put these right here, guys. I'm going to put it on the inside so we've got more room. 30 degrees, and this is 0 degrees. Okay? And I'm actually just going to count by 30s. Look, okay? Because we know this is going to be 45. But I'm going to count by 30s. This is going to be 60, right? This is 90 degrees. I'm going to keep counting by 30s. This is 120 degrees. I'm going to skip this one because that's multiple of 45. This one is 150 degrees. And this one is 180 degrees. Okay, if we keep this on rolling, this is going to be 210 degrees. Skip this one. This is again a 45. This is, well, let me put this down here so it's the same. 240 degrees. This is 270 degrees. This is 300 degrees. This is 360 degrees. Oop, 330, thank you. 330, getting ahead of myself. 360 is one circle, right? Yep. Questions on those? Okay, then we go back and we know the middle ones are 45, so 45 degrees, 45 degrees, well that's 90. 90 plus 45 is 135 degrees. I'm not sure why this is all goofy. 135 plus 45 gets us to 180. 180 plus 180 plus 45 is
245 or 225.
225. 225 plus 45 gets us to 70. 270. 270 plus 45 gets us 315 degrees. Nothing new so far. We've already talked about that. Okay, Mr. Wentz is going to take over, and he's going to go over just those same things, but in radian measures.
So how many radians is 30 degrees? Pi over 6, exactly. Okay. How about 45 degrees? Pi over 4. If 30 degrees is pi over 6, what's 60 degrees? Pi over 3. 2 pi over 6 is also correct, but 2 divided by 6 is 1/3. Okay, how about 90 degrees? How many radians is 90 degrees? Pi over 2. What do you guys think? Do you agree? Yeah. Yep. Pi over 2. Okay. How about 120 degrees? Two pi over 3. Okay. 135 degrees. What was that one?
3 pi over 6. Right?
Not quite. It's over 4 since it's a 45. 3 pi over 4, right? 3 pi over 4. All right, 150 degrees was 5 pi over 6. Okay, remember every 30 degrees we go up by a pi over 6, right? Okay, 180 degrees then, we've gone one more pi over 6 from 5 pi over 6, so we have just pi. Remember when we convert between degrees and radians, that's kind of our conversion factor, is pi radians is 180 degrees, they're the same thing. So we were at 6 pi over 6, if we go in one more pi over 6, we're at 7 pi over 6. 5 pi over 4. 5 pi over 4. Okay. 240 is going to be 8 pi over 6. What's that reduced? 4 pi over 3. 4 pi over 3. Okay, 270. How many radians is 270 degrees? 3 pi over 2. Okay, there we go. All right, 300 degrees. What was it? Okay. 5 pi over 3. Okay, we have our last 45 one here then. That's going to be 7 pi over 4. And finally, we have 11 pi over 6. What's all the way around the circle? 2 pi.
Again, nothing new. We've already covered that last section. Okay, now we're going to start diving into what's new. Okay, guys, right now, I want us to focus on 30 degrees. Okay, 30 degrees angle, which is right here. Okay, now if I look at 30 degrees, the reference angle, which we talked about last class, remember if it's in quadrant 1, the reference angle is what? It's the same as theta. So if this is our angle, 30 degrees, okay, that is also our reference angle. So I want to make an angle. Now, I'm not going to draw on this. I'm going to go over to my other one. Yeah, don't draw this, just watch. I'm going to make that angle, or that triangle. Okay? Now, what type of triangle is this?
30, 60, 90.
Kyle says 30, 60, 90. Well, we just said this is 30 degrees. That's 90. This has to be 60. Okay? So, what we did before class started, okay, was talk about 30, 60, 90. Now, this is called the unit circle because the radius of the circle is 1 unit. Okay? So this radius, again, don't draw this, that's 1. Okay? So if I go over here, my other document that I opened up, and I draw that triangle, what's my radius? 1. What's this angle? 30 degrees. And that's 90. So how do I get from my hypotenuse of a 30, 60, 90 triangle to the short leg? Divide by 2. The relationship between the hypotenuse and the short leg is 2. Whether you're multiplying by 2 or you're dividing by 2. So I need to divide by 2 here. So 1 divided by 2 is 1/2. Okay? Now, how do I get from the short leg to the long leg? Multiply by the square root of 3. So I have a half, and I need to multiply by the square root of 3. How do I do that? Multiply the top together, multiply the bottom together. What's this in the denominator here? It's 1. So I'm multiplying across. I'm going to get the square root of 3. And in the denominator, I'm going to get 2. This is the square root of 3 over 2. Question so far? Liam?
Could you just leave it as 1/2 times square root of 3?
No.
No.
No. Certainly, yes, you could, but we're not going to in this case. Okay? Now, if I go back over, guys, in the unit circle, think of this as a point, which we did that last class, didn't we? We had a point there, and we did sine, cosine, tangent of that point. Well, if this is a point, and this is the origin, what are the coordinates of this point? Well, how many did I go over? Uh-oh.
3 over 2.
I went over square root 3 over 2, right? And I went up 1/2. So if I go back to my unit circle, this point right here, let me use a different color. This point right there is the point, the square root of 3 over 2, comma, 1/2.
Do you want us to write that down?
Yes, write that down. Why is that point? Because I just showed you on the other page. Based upon a 30, 60, 90 triangle, and from the fact that the radius is 1. Who's still with me? Okay, that's the point right there. Square root of 3 over 2, comma, 1/2. Okay, now, again, don't write this down. I'm going to skip 45, I'm going to go 60. So if I think about the reference angle, again, the reference angle is the fastest way to the x-axis of 60 degrees. There's my angle, 60 degrees. What type of triangle do I have? 30, 60, 90. So if I go over to my other document and I think about that triangle that I just pictured. This is 60. What's my hypotenuse? 1. It's the unit circle. So in a 30, 60, 90 triangle, and if I have the hypotenuse, do I go to the long leg? Go to the short leg. How do I get from the hypotenuse to the short leg? Divide by 2, or it's half of it. So this is going to be 1/2. And this is going to be, well, how do I get from the short leg to the long leg? I need to multiply by the square root of 3. I just did that. Square root of 3 over 2. So if I think about this point that's 60 degrees rotated around the unit circle, how many units did I go over?
Over 1/2, up 3 over.
I went over 1/2 and I went up square root 3 over 2. So you can write this down. This point, oh no. Go back. Here we go. Can you erase for me? You don't want to erase. Okay, it's not going to erase. This is the point. What did we say? 1/2, comma, square root 3 over 2. What do we notice? They're just switched, aren't they? So to get to this point, I went over square root 3 over 2, up 1/2. To get to this point, 60 degrees, I went over 1/2, up 3 square root of 2. Excuse me. Square root of 3 over 2. Are we okay there? I really wish this would go away. Okay, now I want to talk about 45. So, I can't erase that, but we're going to have to imagine. If I go over to my other document, and I think about 45 degrees. This is 45 degrees. What's my hypotenuse? 1. In a 45, 45, 90 triangle, how do I get from the hypotenuse to the legs? I need to divide by the square root of 2, don't I? So if I'm going to take 1 and I'm going to divide it by the square root of 2, we don't like square roots in our denominator, so I'm going to rationalize it. Top and bottom. In the numerator, I get the square root of 2. And in the denominator, I get 2. Square root of 2 times square root of 2 is 2. Can I simplify these at all? No. I cannot. So, in a 45, 45, 90 triangle with the with the hypotenuse of 1, this is the square root of 2 over 2, and so is this. So if I think about this as a point, I went over how much? Square root 2 over 2, and I went up how much? Square root 2 over 2. Back to my other document. This point is the point square root 2 over 2, comma, square root 2 over 2. Questions, comments, concerns there? Okay, keep hanging with me. This is going to be kind of lengthy today. It will get faster as we get going. Part of your test is to make this. So you are going to be doing what we're doing. It'll get easier, and we'll show you shortcuts as we go.
So if the radius of my circle is 1, and I'm going straight up the y-axis, the distance of that radius, what is that point at 90 degrees? 0, 1, right? Okay, so this is kind of acting like our y-axis a little bit. So my point here is 0, 1. For 150 degrees, what's my reference angle? It involves 180. 30, right? If it's in quadrant 2, you take 180 minus theta, we called it, right? So 180 minus 150 is 30. So this angle here is 30 degrees. If I draw in my leg here, I have another triangle, right? Okay, and I have another 30-degree angle. What did we say this 30-degree angle's point was?
3 square root of 2, 3 square root of 3 over 2, and then half.
And 1/2, right? Okay. So we have square root of 3 over 2 and 1/2. Did we change the radius at all?
No.
No. So the radius stayed the same. It's still 1. And we said, okay, this point is square root of 3 over 2, 1/2. If our radius is the same, and we go this way instead of that way, negative. Okay, exactly right. So you got, here we are. Square root of 3 over 2, 1/2. And then one of them has to be negative, right? Which one has to be negative, the x or the y?
The y.
The x, right? We negated the x going left, okay? So negative square root of 3 over 2, 1/2.
The whole thing would be negative, right? Or not just a square root? I don't know if that would be.
Where?
Right. Is the whole thing that whole x would be negative?
Yes. Yes. Okay. What's my reference angle for 135? What's 180 minus 135? 45, right? Okay. So,
Go over the top, Mr. White. That's left there. Another one.
do one more time, or is that right?
One more time. Maybe go with it.
Okay.
There we go.
So when you go back and forth between pages like that, you have to go back and
Hit pen again.
the pen. Yeah,
Okay.
I found that out.
All right, so we've got 135. We said that that is a 45-degree angle. So what do you think our point's going to be?
Same as when it's square root of 2 over 2, and then 2 square root of 2 over 2.
Exactly, right? It's the same thing as this 45 degrees, only since we went left, we have to turn the x into a negative. So we're going to have negative square root of 2 over 2, square root of 2 over 2. Okay, and then our reference angle for 120 is 60. So what do we have to do up here? Negative 1/2. And what's my y? Square root of 3 over 2.
Moral of the story here. If we are in quadrant 2, what do we do? Negate an x. The x. Now, if you think about it, in a coordinate plane, points in the first quadrant are both positive, aren't they? Points in the second quadrant, well, the x is negative and the y is positive. What about quadrant 3? Both negative. What about quadrant 4? The x is positive and the y is negative. So when we get into quadrant 3, it's going to be the exact same numbers, except they are both going to be negative. Now, guys, one thing that'll help is thinking about it as far as being a reflection. Okay? So if I reflect 30 degrees or pi over 6 over, do you see how I get to 150? It's reflected over the y-axis. Now if I take 150 or 5 pi over 6 and reflect it over the x-axis, now I'm going to be down at 210 or 7 pi over 6. So 7 pi over 6, the coordinates here are going to be what? Negative square root 3 over 2, comma, negative 1/2. Well, 45s are always the square root of 2 over 2, comma, square root 2 over 2. But they both have to be negative. And then lastly, 240 degrees, well, that's a reflection coming down of what? From what? 120, right? 120 down to 240. So that's going to be negative 1/2, comma, negative square root 3 over 2. Guys, we're using the same three numbers, aren't we?
Yeah.
Over and over and over again. Mr. Wentz going to finish. I guess I forgot 180.
So what would 180 be? Negative 1, 0, right? You went 1 left on the x-axis. Negative 1, 0. 270 would be 0, negative 1, right? Okay. 5 pi over 3. Anytime we have one of our radians over 3, we're talking about a 60-degree angle, right? 60-degree reference angle. So that's good. Our 60 degree, does the half come first or does the square root of 3 over 2 come first? The half, right? So this is going to be 1/2 square root of 3 over 2. And which one's negative? Square root of 3 over 2. Okay, like Mr. Cole said, anytime we have a 45-degree angle, we are having square root of 2 over 2. And since we're in the fourth quadrant, the y is negative. What's 11 pi over 6 going to be? Square root of 3 over 2. And negative 1/2. Exactly. Finally, 2 pi is going to be 1, 0.
That is the unit circle. Okay, we need to be able to construct that for the test. We're going to construct it all over again later in the hour. Okay, it will go much quicker the more times we do it. It'll go much quicker the second time because you don't have to listen to me blab the whole time. Now, why are we doing this? What in the world is the point of this silly circle? So let's go back up to the top. We've been doing trigonometry, sine, cosine, tangent, okay? And right now, if I think about the unit circle, well, first of all, the unit circle has a center of the point 0, 0, and has a radius of 1. If I was smart, I would have already drawn a circle in here. Appreciate that, guys. You could have inserted with a lot of smart comments there, but you didn't. Making fun of how not smart I am. I appreciate that.
Would you like us?
No.
You're welcome.
Okay. Now I'm going to pick a point. Let's just pick this point right there. We already know this, but this distance, that point, is over this many units, right? That represents our x. We went over that many. And this represents our y. Right? So to get to this point is the point x comma y. In a general sense. We went over x units, up y units. And our radius is always 1. All right? So now we're going to start applying sine, cosine, tangent to the unit circle. So if I think about, this is my theta, this is my angle in quadrant 1. If I think about sine is the opposite over the hypotenuse, isn't it? So in this case, it's y over my hypotenuse, which is 1. Now anything divided by 1 is
1. Or itself.
just itself. So the sine of theta in the unit circle is just whatever the y coordinate is. Because the hypotenuse is 1. If I think about cosine, well, cosine is which two sides again?
Adjacent over hypotenuse.
The adjacent over the hypotenuse. So the adjacent is x over the hypotenuse, which is 1. X over 1. And we just said that anything divided by 1 is just itself. So the cosine of theta is just the x coordinate. Tangent is opposite over adjacent, so that's going to be y over x. So to find tangent of an angle using the unit circle, we're going to take whatever the y coordinate is, divide it by the x coordinate. Okay? And these are just the reciprocal. So this is going to be 1 over y. This is going to be 1 over x. And this is going to be x over y. Okay? Now, Mr. Wentz is going to go over the backside with you, but just so for an example, just a very easy description. If I want to know the sine of pi over 6, okay, the sine of pi over 6, well, pi over 6 is how many degrees? 30 degrees. So if I wanted the sine of 30 degrees, up above it says that sine is which value? The y coordinate. So I go to 30 degrees or pi over 6 and I look at the y coordinate. Half. Sine of 30 degrees or pi over 6 is a half. So it's a way to kind of cheat. It's a tool that we can use to evaluate trig functions. Okay? Top of the second page, please.
How did you say?
So at the top of my test for like probably, I don't know, 3 or 4 years, depending on what maths I was in, if we were doing trig stuff, I always wrote this at the top. I always wrote cosine, sine. Any ordered pair is always x, y, right? So that helped me remember cosine is always x, sine is always y. Okay? So we're looking for the sine of 7 pi over 6. Let's go back up to our circle here. What angle is 7 pi over 6? 210. Okay, is sine x or y?
Y.
Y. And what's our y for 210?
Negative half.
-1/2. So that equals -1/2. Okay. Secant of 5 pi over 4. 5 pi over 4 is 225. Up, not down. Okay, secant. What is secant the reciprocal of? Sine or cosine?
Cosine.
Cosine. Okay, so cosine's always the x. So we're looking at negative square root of 2 over 2. But we want the reciprocal, right? Because we're looking for secant. So flip those. You get -2 over square root of 2. And then what do we have to do? Rationalize it, right? That felt good. Times by square root of 2 over square root of 2. You're going to get -2 square root of 2 over square root of 2 times square root of 2 is 2. What's -2 divided by 2? 1. -1. So what we're going to have here, secant of 5 pi over 4 is equal to negative square root of 2. All right, remind me, what's tangent again? Is it x over y or y over x?
X over Y.
Look back up at the chart we made.
Y over X.
It's y. It's y over x. Okay. So we come down here. We're looking for the y over x of 5 pi over 6. 5 pi over 6 is right there. So y over x, we're going to have 1/2 over negative square root of 3 over 2, right? So write that in. It's going to look really weird. If you're dividing by a fraction like that, what are you really doing? Multiplying by the reciprocal. Exactly. So what this really says is 1/2
Bottom right, the negative sign there.
all right, 1/2 times the reciprocal means you flip that bottom fraction, right? So you're going to have 2 over negative square root of 3. Since we have a 2 in the bottom left and a 2 in the top right, we can cancel those, right? So that goes away, that goes away. We have 1 over the negative square root of 3. Are we done yet? Not quite. Rationalize your denominator. So that's going to give you negative square root of 3 over square root of 3 times square root of 3 is just 3. So tangent of 5 pi over 6 is negative square root of 3 over 3. All right, if tangent is y over x, what's cotangent? X over y. Okay, what angle are we looking at for 2 pi over 3? $120. We're looking right up here, right? And we said cotangent is x over y. So we're going to bring that down. We're going to have negative 1/2 over square root of 3 over 2. Same thing, right? If you're dividing by a fraction, you need to multiply by the reciprocal. So that's really going to be times 2 over the square root of 3. Gah! Okay, your 2's are going to cancel. You have negative 1 over square root of 3. Rationalize your denominator. You get negative square root of 3 over 3. Cosecant, what was that again? Was it opposite of sine, so it's 1 over y. Okay, so we're looking for 1 over y. 5 pi over 3 is, we're going to just bring that y right along with us everywhere we're going. There we go. All right, and then I totally forgot what we're looking for. 5 pi over 3?
Yes.
Yes. 3 hundo. Okay, so we got 3 hundo. We said 1 over y. Our y is negative square root of 3 over 2. So we're going to come down here. 1 over negative square root of 3 over 2. There's that y. All sorts of fun today. Oh. All right. And I think that's negative. Yeah. Dividing by a fraction, multiply by the reciprocal. So really we're taking 1 times the negative 2 over square root of 3. 1 times anything is just itself, right?
Right.
So negative 2 over square root of 3. Are we done though? No. Need to rationalize it. So you get negative 2 square root of 3 over 3. What's 3 pi over 2 again as a degree measure? 270. What did we say our numbers were for 270? It was, I think, 0, negative 1, right? Cosine is x or y. So isn't cosine of 3 pi over 2 just 0? Yeah. Sweet.
What do you know about that?
It's 0. That's what I know about that.
I was having a good time.
All right. Yes.
Yeah, do the next one. Maybe the next 2, and then we'll call it quits.
Okay. Sounds good. Do you want to do the cosecant of negative 2 pi since that's undefined, or just?
Please.
Okay. I want to look at cosecant of negative 2 pi real quick, okay? So negative 2 pi, we're starting at 3 o'clock. Are we going clockwise or counterclockwise?
Counterclockwise.
No, clockwise.
Counter of counterclockwise. We're going clockwise.
Slide.
Okay. 2 pi means we went all the way around the circle, right? So we're back at 0, 2 pi. So if you look back up here, cosecant is 1 over y. Cosecant is 1 over y. Okay. What's our y value here? 0. So I'm going to write that out real quick. Got 1 over 0. Can we divide by 0? No. Just like in slope, when you have something over 0, this is undefined. Okay? So be careful, because that's not 0, right? If back up here we had one that was 0, cosine of 3 pi over 2, that was actually 0, because it was 0 divided by something. This is undefined, because we're dividing by 0.
That's our answer.
That's your answer. Okay? Do you want him to write it a different way than that, or is that okay? Okay. All right. Jake, what's your favorite number between 3 and 9?
7.
7. 1, 2, 3, 4, 5, 6, 7. Okay, we're doing tan of 5 pi over 4. Okay? So go up to 5 pi over 4. 225. Okay? We got negative square root of 2 over 2 and negative square root of 2 over 2. Tan is y over x or x over y? Y over x. Okay? In this one, you're absolutely right, Cole. It does not really matter. Because we got negative square root of 2 over 2 divided by negative square root of 2 over 2. What's anything divided by itself? 1. Uno. All right, any questions? Yeah, Sydney.
Would you like one of the negative ones, like tan is negative pi over 3?
Yeah. Where's that one at? Right up here?
Yeah.
Yeah. So tangent of negative pi over 3. First, you need to find your reference angle, right? So negative pi over 3 means you went 60 degrees down to the right? Basically. Okay. So if you go back up to our unit circle, if you go from 0 and go right, come on. And you go down to the 61, you got 300, right? Or 5 pi over 3. So here's our point. And you said it was tangent, right? Okay. Tangent is y over x or x over y. Y over x. So we're going to have negative square root of 3 over 2. Negative square root of 3 over 2 over 1/2. Dividing by a fraction, you multiply by the reciprocal, which means I'm really multiplying by 2 over 1 is just 2, right? The 2's cancel because they're opposing. So tangent of negative 5 pi over 3, or negative pi over 3, sorry, it's just negative square root of 3. Okay, so if it's negative like that, you need to find the reference angle. Okay? All right, good question. Anybody else?
Word sheet today?
No.